All right, starting chapter 8. This is actually, the whole chapter is over trigonometry, which is, you're going to see this in pre-calculus, like the whole entire time. So this is a prelude of what you're going to see in pre-calc. First, let's do some definitions. So a periodic function, it repeats a pattern of y values I'll leave it at that. Repeats a pattern of y values. So the key word in this definition is y values. All right, a cycle would be one complete pattern. So the key word here, I guess, would be pattern. Okay, so the next thing is the period of a graph. That is the horizontal length of one cycle. The key word here would be horizontal length. All right, now amplitude means height. So to figure out what that is of a graph, which if you look down here, we're going to get into these types of graphs. So to find the amplitude, I'm just going to put the formula here. To find the amplitude, you take half of the maximum y value minus the minimum y value. And that's how you find the amplitude. Okay, so we need to figure out if these functions are periodic. And if they are, we got to find it. So we're going to say yes or no first, and then we're going to say what it is if it is periodic. All right, so what you need to do is you need to figure out where you want to start. We have to figure out, first of all, if we have a pattern, I guess. So I always like to look at the y-axis, which is right here. So on the y-axis, my graph starts down here. So it goes up, it goes down, and that's when it repeats. So what I traced here is this shape. I have this shape over and over again. It's going to keep repeating that pattern. So since I have a pattern, that means it is periodic. So first I want to figure out, I guess, if there's a pattern. And now that we say there's a pattern, we have to figure out what it is. So if I go back up here and look, the period is the horizontal length from where it starts to where it stops. So I started here at 0, because remember horizontal means the x-axis or the x values. And it goes until a little bit past 3. So we'll say the period would be 3 1/4 maybe. That's just a guess. We don't really know, it's not accurate. Okay, number 6, I'm going to again locate the y-axis. On the y-axis, it looks like it starts here. So I go up and down, and then it repeats right there. Now you can really start anywhere. You could have started here, and then it would stop here, and then you have a bunch of these repeating over and over again. But the reason I like to start here is because I'm always starting at 0, and that way, wherever it starts over, that's what the length of the period would be. So from 0 to a little bit past 2. Actually, it might be exactly 2. So yes, it's periodic, and the period is 2. It has the same height above and the same height below. Now, this one is not periodic because it's not consistent going this way. It has to be like parallel to each other. If you look, it keeps going up this way and it keeps going down this way. They're not parallel. So it's not the same across the top and it's not the same across the bottom. So this is not periodic. Okay, let's move on to the next page. Okay, so let's go ahead and I'm going to skip number 9. I don't think we need that many examples. Okay, so number 8, here is my, well, first I want to figure out if it's periodic, and I guess I didn't really have to draw on my y-axis before. I can just tell by looking at it. So I want to figure out, is it the same height above, which it is. It doesn't go past this point, and it's the same height down here. I guess not height, but it stays in between these two lines. It doesn't stay, it stays within that range, I guess is what I'm trying to say. My graph stays within that range. It doesn't fluctuate. It's constant. Therefore, it is periodic. So I want to figure out what the period is. Now these directions are a little bit different. It says identify one cycle in 2 ways. We're not really going to do that. That just kind of tells you to find a starting point and a stopping point. We just want to, again, find the period. So since it's periodic, I'm going to find the y-axis. Looks like it starts up here. And the next time it's up there is right here. And then it starts over. So I have a bunch of these throughout my graph. So from here to here would be considered a period. It's a little bit past 3. And it's not going to be accurate, so I'm just going to say 3 1/3. It's just a guess. It's about 3 1/3. Number 10 is also a period, or it's periodic, because it's the same going across this way, and it's the same going across down here. So it stays in between these two lines. It doesn't go higher, doesn't go lower. It stays within this range. So now I got to figure out what the period is. So there's my y-axis. Starts up here. The next time it's up there is right here. So I got a bunch of these repeating throughout this graph. So 0 to 4. So my period is 4. All right, that's the period. Okay, on 11 and 12, this time I want you to find the period and the amplitude. I'm just going to focus on the amplitude because I think hopefully we are good with how to find that. Okay, so there's a formula for the amplitude. You take half of the max minus the min. And this is for the y values. Okay, so what I need to do is find the highest y value. Well, first I need to figure out, I guess, where the origin is. That might be helpful. The origin is right here. Okay, so the highest it goes is right here at 1. The lowest it goes is -1. So the maximum is 1 minus the minimum is -1. Well, this really becomes plus. That's 2. Half of 2 is 1. So the amplitude is 1. Now, if it's the same distance from 0, so like this was 1 and this was -1, if it's the same distance, then the amplitude is always going to be the absolute value of those numbers. But if they're different, then I would suggest using that formula. Okay, so on this one, again, I just want to find the amplitude. So I'm going to locate the origin right there. And I want to find the maximum y value and the minimum y value. Okay, so let's see here. The maximum is 3. the minimum is -1. So that becomes plus, that's going to be 4. Half of 4 is 2. So the amplitude is 2. All right, moving on. I'm going to cross off 14 and 16. Actually, I think we're good with amplitude, so I'm going to cross off all these. We're going to get on to the next part of this lesson, which are special right triangles. We're going to use this to do the questions on the next page. So in geometry, you talked about special right triangles. The first one's going to be a 45, 45, 90. And then if it's a 45, 45, 90, then these are both x. And this is x root 2. This one we will say it's a 30, 60, 90. And the sides are going to be across from 30 is x, across from the right angle is 2x, and across from 60 is x square root of 3. Okay, now we're going to have to use those examples to do the next page, which I think is also the last page. Okay, and I'm not going to do 21 or 22, so I'm going to cross those off. I'll just do these 4. All right, so I'm referring to, move some things out of the way here. So I'm referring back to these 2 diagrams to do these 4 questions. So let me rip this out. Okay, I think I'm ready now. I need to see this too. Alrighty, so what I need to do is first of all label my triangle. So obviously 17 or 8 and 18 are 45, 45, 90s, because if you look at the 2 sides that are labeled, they're the same. Now these are labeled differently than these. So what I'm going to do is relabel this. So the 2 sides that make up the right angle, these are x's. And this should actually be x square root of 2. I'm going to get rid of that. Okay, so what I need to do is I have to figure out what all the sides of the triangle are. Well, I already know that these 2 are 8. I just got to figure out what this side is. Well, I already know what x is. X is 8. So this side should just be 8 square root of 2. That was easy. Okay, now this one I have a square, but I only care about the right triangle. I don't care about both of them. I'll just look at this one. So I'm going to label the sides as it's labeled on here. So the 2 sides that are the same are going to be x. So I'm going to change those to x's. And this is labeled as x square root of 2. And I don't care about these because I'm only looking at one of the triangles. Okay, this time I do not know what x is. So this one's not as easy. So first I have to figure out what x is. So I know that this side, which is 6, is labeled as 6 square root of 2. So I'm going to set those equal to each other. So if you don't know what x is, you got to find it by making an equation. Now first of all, I already know this is 6, so I'm done with that side. I just got to figure out what x is. So to do that, I need to divide by the square root of 2. But if you recall, you cannot have a radical in the denominator. So what you're going to have to do is rationalize the denominator. So if you multiply across, you get 6 root of 2, and then that's going to be 2 on the bottom because that's the square root of 4, which is 2. And then you can reduce the 6 over 2, which is 3. Okay, so this is what x is equal to, which means both of these sides are 3 square root of 2. So now we have all 3 sides of the triangle labeled. So if you know what x is, it's easy. if you don't know what x is, you got to find it. Okay, let's move on to 19 and 20. All right, this time we have a 30, 60, 90 triangle. So I'm going to be looking at this one right here. I'll be looking at that. All right, so the first thing I want to do is label the sides of my triangle. So right across from 30 is x. Right across from 30 is x. Right across from 90 is 2x. And then right across from 60 is x root 3. First thing you want to do after you labeled it is if you want to see if you know what x is. I do not know what x is. So now I got to find the side that I know. I know this side's 25. So I got to find what x is. So what I'm going to do is I'm going to set these two things equal to each other. Whoops, that's not right. And then I'm going to solve for x. So I'm going to divide over the square root of 3. Can't have a radical in the denominator, so I have to rationalize that. So I'm going to multiply both numerator and denominator by the square root of 3. So I'm going to get 25 square root of 3 on the top, and that's going to be the square root of 9, which is 3 on the bottom. These two things do not simplify this time, so this is what x is equal to. Therefore, this side over here is 25 root 3 divided by 3. This side is 2x. It's 2 times this. So if I multiply this by 2, which is 2 over 1, everything stays the same except for this 25 turns into a 50. 2 times 25 is 50. So this is 50 square root of 3 divided by 3. All right, last one is number 20. Okay, so first I want to label my triangle. So right across from 30 is x. Right across from 90 is 2x. And then right across from 60 is x square root of 3. All right, so I do not know what x is. It's not labeled. This side's labeled though, which is 9. Therefore, I'm going to set these two things equal to each other. I know that 2x is equal to 9, which means x is equal to 9 halves. So now I know that this side is 9 halves, and this side is 9 square root of 3 over 2. Because I just put whatever x is right there. So now I know all 3 sides of the triangle. All right, so that is 8-1, our first section on trig.